Hello everyone. So today we are going to discuss about drift detection. So I'll be talking about classifier-based drift detection in this video, which uses sklearn as a backend. So basically, guys, there are many methods which can be used for drift detection. For example, there are certain online methods, there are certain offline methods, and ultimately they all use some or other kind of statistical methods. Okay, and then on top of that, certain libraries are being created. For example, Sheldon has created Alibi Detect, and there is the library named H2O.ai. Okay, so in this series, I'll be creating multiple videos, and I'll be explaining different methods ultimately. Okay, so let's start with today's classifier-based drift detection. So what classifier-based drift does basically? So it trains a classifier named as a detector on reference data. So basically, we divide the data set in three different parts basically. So two different parts, X reference and XH naught. So X reference basically is similar to your training data on which we'll be training the detector, and XH naught is similar to your test data on which you will be checking whether there is a drift or not. So ideally, the expectation is like XH naught we will be generating from the same distribution of data, which is similar to XREF. So there won't be any drift in XH naught. And then we'll be also generating a third kind of data which is different from these two. So when we'll be running the drift detector on this data, so it should identify, okay, there is a drift. Okay, so that's the whole idea basically. So how classifier-based drift detection works, it try to check whether a new record is similar to your reference data set, and it assigns a probability value to that new record. And if probability is very high, then it says, okay, there is a trend. This data is not similar to the reference data. Okay. And in behind the scene, it uses hypothesis concept. So it assigns null hypothesis and alternate hypothesis. And based on p-value, it differentiates the records. So that's the whole concept in a nutshell. But in next videos, I'll be explaining the complete theoretical and conceptual overview of each and individual method. But today, let's understand and get the implementation feel with sklearn as a backend. Okay, so let's start. So for that, I hope you know how to create the content environment. So you just create a content environment and then install Alibi and Alibi Detect inside that one within user account. Okay. And the data set I'm using, so I have downloaded from this UCI machine learning repository. So here, if you go, so there is an adult data set available, and from data folder you can download. Okay, so I have downloaded all these things, and then with the help of this data, I'll be generating a data frame. Okay, so here, if you see, like I'm importing pandas library, that's fine, and from data folder. So if you just see here, inside that I have downloaded all those files and kept here. Okay, so adult.data, it's normal like this data without the headers. Okay. And then we have other like names. It will have all the feature name basically. So let me read it. So after reading, and I can show you. So it has read the same data. Okay. And it has a blank header. So that's where it has assigned index 1, 2, 3 like that. Okay. And then I have a column. So columns I have taken from this adult dot name. So if you just open this one, then here you will see, you will find so all the columns. If you go little down, then here they have mentioned all the columns. Okay. And then their description what all that column does basically. Okay. So you can read about that. So from there, I just took all these columns and then generated a data frame. So pd.data frame, I've given data values and as array and then columns. Okay. In the moment I run this, then it will generate a data frame, and then here you can print. So now you see it has assigned a feature name for each column. Okay, so this is how your data set looks like. So this is the data set I'm going to take. So the guys, the normal machine learning problem is with this adult data, like classify the high income group and low income group classes. Okay, so that's where this class is your target variable. So less than 50K or more than 50K. Okay, so this is the if you are going to build a machine learning model, so that's the problem statement. Okay, but I'm not going to build a machine learning model. So assuming that you have already built, so at the end I will show something related to model, but that's later stage. So now I'm going to build a classifier based drift detector. Okay, so now let me explain the whole working which I'm going to do with the help of this diagram. So this is your data set, and then to classify those in a high income group. So I'm just differentiating based on the education group. So I am again subsetting because I need two different data set to identify the drift. In one, I also there is no drift. In other, I also there is a drift. Okay. So for that, I have again subsetted this original data set into two categories. One is like lower education categories, which corresponds to lower income group, and education categories, which corresponds to higher income group. Okay. So based on that, I will subsetting. So I will have X low and X high two data set. And then again, X low, I will divide in X reference and X H naught data. So basically, these two are coming from low income education categories. So these two are similar, but this is coming from high income education categories from this main data set. So that's why this will be slightly different from these two data sets. And that's where ideally the drift should be detected in this data set. So I'm going to train a classifier on this train data set and will be validating on this. So expectation is like when I will run this drift detector on this data set, so it should output no drift. And when I will run the drift detector on this data set, so it should tell, okay, there is a drift present. Okay, so this whole concept I'm going to implement in this video. Okay, so let's start basically. So if you just print a data dot column, so you will see all your columns basically, that's fine. So again, guys, here I'm going to build a classifier based drift detector. So you have to do processing similar to how you do it model training. Okay, so you have to segregate your categorical column and numerical column. So here I'm defining these are our categorical columns, and then one more thing, when I was just going through this categorical column, I found, so let me execute and then show you. Okay, so it's fine. And then if I just run this, so there is a problem, guys, here in education column. So these categories against education column has some space before this value. Okay, so similarly, I also observed like this space was present in all other categories. So that's not what I did basically. I just removed this space. So what you can do, so this commented part you can see like for all categorical column, what I'm doing, idle data and this category. So for example, this feature basically the column name for this column, I want to do str.strip. What it will do, it will remove all trailing and starting spaces from the values of that feature. Okay. Similarly, you can do for all other columns. Instead of doing that, what you can do, you can create a for loop and then do the same thing. Okay. So after that, the moment I run this, then it will remove all those spaces. So now if I run this again, okay, I will run this block again here and I can show you. Now spaces will be removed. So for example, see, there is no space here, but there was a space here. Okay. So this is a little bit processing we did here. And then we have a numerical columns defined. So the same thing I wanted to show. So just remove this. Okay. And then as I said, I'm going to create two data sets. One is with respect to low income group education categories. So these education categories I defined, they are corresponding to low income group. And these income categories are defining to high education group. Okay. So for example, what you can do. So here, if you do adult data education.unique, so here you will see these are different education categories available under education column, education feature. Okay. So you can group certain categories as which corresponds to low income group and certain high income group. It's up to you. Okay. I just want to create two different data sets. So I just created these categories here and defined as a low income group and these education categories high income group. Okay. That's fine. So in that way, we'll get two different data sets, basically two different subsets from the original data set. Okay. So now, if you print, so low income group, education, high income group, education categories. Okay. So now this is fine. I don't need to print it again. So let me remove it so that it's not confusing. The low education and high education. Okay, fine. So now we have low education list and high education list categories. Okay. So now with respect to that, what I want to do basically, I want to get the row ID of all the rows which belongs to low education categories, and then row IDs of all those which belongs to high education categories, so that I can get two different subset of data set. Okay, so here I'm just creating a mask for low education and mask for high education. So if you print, so then it will print true, true, corresponding to those rows which belongs to low income education categories, okay, which you defined here. And this will define high education categories row. Sorry. So now what you can do, and now you can filter, you can create a subset. So from adult data dot values, because I want to get a numpy array kind of thing, and then you provide the IDs. So for example, Boolean, okay. So like true, true. So wherever it will find true, it will return those rows and assign to X row. And here again, here high education mask. So where in adult data dot values, wherever it will find a high education ID, it will return those. Okay, so that's what it will do. You can print each and individual variable and you can see how it looks like. Okay, so now you see X low. So let me print also and show you. Okay, so X underscore low. So it will have like this. Okay. So same data in just NumPy array format, and it is returning only those rows corresponding to low income, low education categories. Okay, low income education categories. So that's nothing else. I'm just subsetting the data into two subsets. Okay. So there is no specific, nothing rocket science here. Okay. So now, what next I'm doing, I got X low and X high. So if you just see the diagram, so here we have X low and X high. So these two data set I have got. Okay. Now further, this X low I will divide in X reference and X H naught. Okay. So let's see how we can do that thing. So similar to what we do in model training, we use train test split. So here again, I'm going to do same thing. So here I will just define the size because I want to generate a thousand size. Okay, thousand rows in X reference and thousand rows here. Okay, and thousand row data I'll create this also. Okay, there is no fix. You can create more rows data. That's fine. Okay, but here I just want to use a demo purpose so that model will get trained very early. Okay. So that's fine. So here what I'm doing np.random.choices. So here I'm just defining 1D array. So here xlow.save 0. So it will have this size. So it will return 29,859 here. Okay. And then size 2 into size. So here it will have 2000. Okay. So that's where it will get 2000 randomly data item or rows. Okay. IDs here. Okay. And then those ID you pass here. So that's where from X low, those IDs will be returned, okay, for X reference. And then again, for this complete data, I'm just splitting into 50%. So 50% will be assigned in X reference and 50% will be assigned on X H naught. Okay, so that's how this train test split work, you know all, okay. And similarly, I'm creating a XH1 from high income group. Okay. So that's where I'm using X high. Okay. So here again, I'm giving size only, not 2 into size. So here by default 1000. Okay. I don't need to split. Okay. Those 1000 rows will directly will come in XH1. Okay. So now we have X reference, XH naught, and XH1. So normal data pre-processing. Okay. Normal subsetting. That's it. Nothing extra. And then what I need to do basically, so I got these three data sets you see here. I got X reference, XH naught, and XH1 I got. And now in X reference, I need to train a detector. I need to create a detector. So for that training, I need to handle this categorical variable. So for that, I'll be using one-hot encoding. And for numerical variable, I'll be using normal standard scalar. Okay. So you see here we have these category IDs. So categorical variables so like workplace, education, sorry, marital status. These all are categorical variables, right? So what I need to do, so to do the one hot encoding, I need to know the column index of these categorical variable. Okay, so for how you can get the column index of those categorical features, you can do for X in categorical columns and then do adult data dot column dot get location of this X. So here in categorical column, one by one, it will iterate and it will assign here and it will return the ID location. Okay. So like this, if I just want a print and I show you. Okay. So how it will be. So like in 1, 3, 5, 6, 7, these position categorical variable exist. So for 0 is age, then 1, this is the categorical variable, right? And then 2, this is a numerical variable. Then again 3, this is a categorical variable. Then 5, this categorical variable. 6, 7, this categorical variable. 8 categorical, 9 categorical. Then these are our numerical variable, right? 9, 10, 11, 12. Then again 13 is categorical variable. So like that, we have categorical variable IDs. Okay. And similarly, you have numerical variable IDs wherever numerical variable exists. Okay. Fine. So now I'm going to create a column transformer. So what column transformer will do? So we'll define a transformer internally. It will convert a categorical variable to one hot encoding, basically create a dummy column. And for numerical variable, it will create a standard scalar. Okay. So I import this, and what I'm going to do here, so basically define a one hot encoder. And here I'm defining the categories basically to create the dummy columns. So if you just print the selected row, then you will get these things for each category. So like how many different value categories are there in that column? For that, it will create the dummy basically. So dummyification. Okay. So you know that thing. Then I'm just creating column transformer and here defining a categorical transformer for categorical variable, a numerical transformer for numerical variable. Okay. And then defining the preprocessor dot fit finally. Okay. On complete data so that it has complete categories for each column so that next time when I'm doing fit transform, I can define like only X reference. If I'm just transforming X reference, so it will create dummies with respect to total categories because see, in X reference and X H naught with respect to education, we have more categories, but in X H1 we have only four categories, right? So it should not be like it should create dummy column with respect to only four categories. It should, when I do transform for XH1, it should create dummy column with respect to total categories, right? So that's where here I'm concatenating and giving kind of total uh, categories columns, okay? So that when we do the transform, it will handle properly. So basically here I defined the transformer and now next thing from here onwards, I'm just going to train a drift detector. For that, I just import Alibi Detect.cd. CD is classifier drift. I'm importing classifier drift. And here I just need a random for because I'm going to create a classifier based drift detector. That's where I need some sklearn based model. You can use TensorFlow, you can use PyTorch also as a backend. So that I will be explaining in upcoming videos. So this drift detection series is going to be a little lengthy because lot many concepts, models I need to cover. Okay. So today focus on sklearn based backend. So from sklearn, I have a random forest classifier to define the model and then define this classifier drift and accept these parameters. So the first parameter is like reference data and then the second is like model. So this is the object of random forest classifier and then you need to define the backend and then pre-processing function because here when you like detect, we start detecting. So you will be passing different type of data and that to be processed basically like this transformer should be applied. Okay. And then I have bandized prediction because here I want to for each record in the like XH1 that is new data, I'll be assigning a probability whether this belongs to a reference data or this doesn't belongs to a reference data. Kind of we are classifying. So that's where this is the binary spreading. Okay, and number of fold basically it backend uses like a class validation techniques. Okay, so k is equal to 2. So that's how I defined our detector. And then at the moment I run this, so it initializes this detector, and then the moment I start predicting, so like here CD is object of classified detector, CD dot predict if you do and pass the data on which you want to run this detector. Okay, so I am passing XH naught. Now you see here we are here, so we have our drift detector ready with sklearn as a backend. Now I'm just checking whether it will identify there is a drift in this or not. So ideally, there should not be drift because it is coming from similar data, right? So there should not be any drift. So let's see how it works. So here, if I do cd.predict and I'm passing this fh naught data. Okay. So here, if I run this, so wait a moment. So here it is creating kind of JSON string data, and then each drift is equal to 0. 0 means there is no drift available. And here you see like p-value is 0.99 and threshold is 0.05. As I was explaining in the beginning, it uses a hypothesis concept and it works like a null hypothesis and alternate hypothesis. And if p-value is greater than 0.05, then there is no drift. And if it is less than a 0.05, then there is a drift. Okay, if it is more closer towards zero, then there is a drift. Okay, that's how you can understand. And now you see if you want to print a formatted result, then what you can also do, you can just define certain labels and then you just define a functions here. In this function, what I'm doing, expecting this dictionary object, so this same dictionary, so this output I'll be passing here. And then here, like in which data I'm just running this function. So basically here, if you see, so this will be the output in dictionary format. This, you see here, this one, and then h naught, basically to tell I am running h naught. Okay, I printed here h naught, so it will print like this. Okay, and here format, so labels basically. So label, if you print label 0, it will print no, and label 1, it print 1. Yes, okay. So how to get 0 and 1? So here, like in threads data, you just see this output. Okay, threads data, we are inside here, and then each drift. So each drift will return 0. Okay, here 0. So this complete part will return 0, and then label 0 will return no. Okay, so that's where you can print properly. And then similarly, you can fetch the p-value from this dictionary. Okay, p-value is 0.8. Yeah, you run. So you run at multiple times, you keep on getting different p-value. But of course, it will be way beyond 0.05. Okay, you got 0.98. And then similarly, if you just check on H1 data, okay, then here you will find, okay, there is a drift, yes, 0.001. Of course, it is way less than 0.05. So drift is present. Okay, so that's how classifier detector works basically. For each record, it assigns a probability value. So now you see here, for each record, it is assigning a probability value, which is like more probability means there is a drift. Uh, there is no drift basically. Okay, and less probability means there is a drift. Okay. So basically, a more probability means it is a similar to our reference data. Okay, so high chance it is similar, and less probability means it is not similar. So, for example, if you just see the output of this, then you will understand. Okay, so let me show you the output of this. So now you see here. Here we have kind of mixed probabilities. Like some has high probability, so some records are matching, but some has very less probability, like you see. Okay. So that's why, like, if majorities have less probability, then it will say, okay, there is a drift. Data has changed. If majority are like having high probability, then it means there is no drift. Okay, so you can count. Okay, but idea is that what I explained. So that's how it has detected the drift. What is next? Basically, if there is a need to save this detector and load it in later stages and do that check, basically. Okay. So what you can also do, you can Alibi Detect provide the saving, save detector and load detector. Then save detector, you just provide the detector object and you just give some folder name. So till 4 I have already created. So I've created folder 5. So here, if you see, if you come here, then I have already till 4. Okay, I was just checking. So what you can do, you just create 5. So 5 doesn't exist. Okay, so let me run this. So if so inside site 5, so let's see what all things it has created. So if you just come, this is newly created folder, and inside that you will create a model folder. So model.joblib, it will contain the tag classifier detector, and then we have preprocessor functions because all new data on which you are checking whether drift is present or not. So it will be pre-processed basically. Okay, and then config.2ml, it will have all configuration detail like hyperparameter, everything to train the detector. Okay, all those. So this will be used like when you are going to deploy this detector and kind of generating a Selenium API. Okay. For that time, it will be used and similarly this. And then this also contains reference data because against this, it will be checking the new data, whether it is similar or not. Okay. So these all details it generates basically. Okay. So this is how you can save it. And then if you load, then the same thing, load detector you can use, and then you can do the prediction. Okay. So this is how it works. Yes, but next question comes like, what if you don't have these detectors in place? So that's where I have quickly created a model, random forest classifier on the same data and trained the model on X reference data. Okay, so if you see here, so in this data, I'm going to create a random forest classifier. Okay, so this is our training data, and in this, I'll be testing our random forest classifier. Okay, now I'm creating a model, not the detector. Okay, and then you will see in this data model, actually, model performance will be very high. But when this data, so this is the new data I'm treating. Okay, and here you will see model performance is very low. But what will happen? reality, you will not have ground truth available here. So how you will know model is performing good or not? Model will predict certain outcome. Okay, it will still classify a high income or low income, but you don't know whatever it is classifying that is correct or not until you have in future ground truths are available. But today, how you know, right? So for that, drift detectors will be in place. So let me show this part also quickly. So what happens? So this part is fine. I'm just preparing the data which I have already talked about quickly. And now here you see. So I'm importing random forest classifier, and here initializing the scale of a random forest classifier with certain hyperparameter, and I'm using reference data. Okay, reference transform is after doing column transform like categorical and numerical column treatment. Okay, and then here I'm passing y train corresponding y values. I trained the classifier, and then here I will just do the prediction on x h naught. So x h naught is your this data. So this data, right? So here model performance would be high. So let's see how it is performing. So just let me run this. Okay. Okay. So now in XH naught, so this predicted value are corresponding to XH naught. And for this corresponding, we have real values Y test. Okay. So here you see we are getting around 80% accuracy. So it's fine. Okay. Now let's see how it is behaving on XH1. So that is our new data. So with respect to high income, so here we have different education groups altogether. Distribution got changed, right? So this is the new data. So here model performance would be low as expected. Okay. So let me predict those values also. Okay, and then that's fine. So here, if you see like YH1, so Y values, I mean real values corresponding to H1 data and predicted values for that H1 data. Okay, so here you see we have accuracy around 63%. So it's way less, right? But because I just kept Y values here just to compare, but in real time scenario, you will not have this Y value available with you. So you will have only these predicted values. So only these values you will have 0, 1, 0, 1, right? Predicted values, or you can also map it to the classes. So, but how you will know whatever model is predicting it is correct or wrong? Because if real values are available today, then why you will have a model, right? You don't need to predict because you already know the output. You always predict for future, right? And that's where you don't have real values available. So how you will know like model is producing right or wrong? So that's where drift detectors comes in place. You need to deploy a drift detector component along with your model so that whenever you have new data, you can, of course, you can schedule based on use case to use case, requirement to requirement basis, but you can schedule, for example, bi-weekly or weekly or monthly. Okay, based on use case you want to check on new data. You can check. So, for example, there are certain detect like online detector. So you can check on every record. So that's where I said it depends on use case. But whenever new data is coming, you need to pass through a detector and then identify whether data distribution got changed or statistical property got changed to the reference data. If they are changed, means drift is available. Then you need to trigger an alarm, which will trigger a model retraining so that model can be retrained and so that it adopt the new pattern as well, and then you redeploy that model with newer version, and then you start predicting. So that's where over the period of time model performance will be constant. There won't be much deviation on model performance. Okay, so that's all about today's session. So I hope at least now you have some fair amount of understanding how drift detection works in general. Okay, but there are lot many methods, lot many libraries to detect this drift. Okay, so I am going to talk one by one, and I will also create one video on theoretical concepts to clear like there are different types of drift. For example, data drift, concept drift, also known as model drift. Then we have covariant drift. Okay, are they similar or different? How they are different? How they are similar? Okay, how to detect? All those things I will be talking. Okay, so that's it for today's video. I hope your concepts got clear. You like the video, and if yes, then please don't forget to subscribe my channel and share within ML community. That's how you can support me. So that's it. Thank you very much.